Hey there, students! Got an exam coming up? Need to review Chapter 11 fast? Well, you are in exactly the right place. Welcome to this super quick explainer. We're going to revise your entire science chapter on light, shadows, and reflections. I'll be your guide today, and together we're going to break down these concepts so clearly that you'll be completely ready to secure those full marks. So grab your notebooks, get comfortable, and let's jump right in. To kick things off, I want you to picture looking up at a beautiful, glowing night sky. Classic scene, right? But I've got to start with a classic trick question to test your basic knowledge right out of the gate. Does the moon actually produce its own light? Keep that question in the back of your mind, because the answer is literally the foundation for everything else we're about to learn today. All right, here's our roadmap for this explainer. First, light and materials. Second, how shadows are formed. Third, mirrors and reflection. Fourth, a quick recap. And finally, some crucial exam tips. Section 1, light and materials. Let's do this. So let's answer that moon question. Did you guess the answer? If you said no, you hit the nail right on the head. The moon is a non-luminous object. It doesn't actually emit its own light, it just reflects the light emitted by the sun. Objects that do emit their own light, like the sun, a torch, or those modern LED lamps you see everywhere, are called luminous objects. And by the way, LEDs make awesome luminous sources because they use way less power and last forever, which is exactly why they're so popular nowadays. Now, you can easily memorize these three material types for your test by just thinking of them as a spectrum. It's all about how much light gets through. If light passes through almost completely, like through a clear glass window, it's transparent. If it only passes through partially, giving you a kind of blurred view, think frosted glass or tracing paper, it's translucent. And if the material totally blocks the light, like a wooden desk or a thick textbook, it's completely opaque. Okay, look at the setup here. Notice how the student looking through the straight, hollow pipe can clearly see the candle flame, but the student with the bent pipe, they can't see a thing. This really simple activity is a massive proof for your exams. Light always travels in a straight line. It absolutely does not bend around corners on its own. Moving on to Section 2, how shadows are formed. Building on that straight line property, you absolutely must have these three exact ingredients to form a shadow. If you miss even one, no shadow. First, you need a source of light. Second, you need an opaque object to block that light. Remember, opaque means zero light gets through. And third, you gotta have a screen or a surface behind the object to actually catch the dark patch where the light couldn't reach. A shadow is literally just the absence of light on that screen. And this perfectly illustrates a really common exam question. How does distance affect a shadow? Just look at the football and the torch. When you move the light source closer to the opaque object, the shadow on the screen gets significantly larger. If you move the light further away, the shadow shrinks. It's all about how much of that straight path of light is being blocked. Pretty cool, right? Section 3, mirrors and reflection. So what happens when light hits something smooth and shiny instead of just being absorbed or blocked? Well, this brings us to reflection. Definitely memorize this exact phrasing for your tests. Reflection is the change in direction of light when it falls on a shiny surface, like a mirror. Since light travels in straight lines, hitting a smooth, flat mirror makes it cleanly bounce off in a new, straight direction. This simple idea is exactly how periscopes work. By setting up two mirrors in a Z-shaped tube, soldiers can safely look out of bunkers and submarines can see above water, just by bouncing light around corners. But before we talk more about regular mirrors, I want you to imagine building a simple camera using two cardboard boxes, one sliding into the other, with a tiny pinhole at one end and a tracing paper screen at the other. When light from a bright object, let's say a distant tree, passes through that tiny hole, it travels in straight lines. Because the lines from the top and the bottom of the tree physically cross at the pinhole, the image you see on the screen is actually upside down. In science terms, we call this an inverted image, and it's very different from a standard mirror reflection. Let's contrast that pinhole camera with a standard flat mirror, which scientists call a plane mirror. When you look in a mirror, the image is the exact same size as you are. It's erect, which is just a fancy science word for upright. Your head is still at the top. The image cannot be obtained on a screen. It looks like it's trapped behind the glass. And finally, it's laterally inverted. Think about how the word ambulance is written backward on emergency vehicles. When a driver looks in the rearview mirror, lateral inversion flips it left to right, so it reads perfectly normally for them. All right, Section 4, quick recap. Take a deep breath. Let's lock this into your memory. If you can just remember these bullet points, you have already mastered the core concepts of this chapter. Ready? Light always travels in straight lines. Transparent materials let light fully pass, while opaque materials block it entirely. To get a shadow, you absolutely need a light source, an opaque object, and a screen. And lastly, a plane mirror reflects light to create an image that is upright, the same size, and flipped left to right. Section 5. Exam Tips. Now for the gold mine. Keep these specific tips in mind, and you're going to easily score full marks on those tricky true or false or multiple choice questions. First, never fall for the trick that the moon produces light. It is highly reflective, sure, but strictly non-luminous. Second, never forget that a shadow needs a screen to be seen. In vocabulary matching, erect always means upright, while laterally inverted means left to right flipped. And if a question ever asks about a pinhole camera, the image is always inverted, meaning upside down. I'm going to leave you with this mind-blowing fact from your textbook. Light moves incredibly fast, but space is just vast. Light emitted by the sun takes about 8 minutes and 20 seconds to reach the Earth. That literally means if the sun were to suddenly disappear, we wouldn't even know about it for over 8 minutes. Kind of makes you wonder what else in the night sky we're seeing exactly as it was thousands of years ago, doesn't it? Keep that sense of wonder alive as you study. You are now fully ready to crush your exams. Keep learning, and good luck.